Let's welcome our expert speaker, Sanchit Jain, who is AWS certified engineer with almost 7 years of IT experience in designing and building distributive big data application on cloud. Currently, he is working as a technical lead architect at Quantify. Also, he is part of an AWS partner ambassador and AWS community builder. He is well versed with AWS technology and he will be conducting this interactive session. So try to take as much benefit as possible to gain the required knowledge for placement and higher studies. So over to you.
Thank you. Thank you so much for that warm welcome, everyone. Just one request. Is it possible to enable the chat so people can interact with it?
Sir, it is not possible. They can unmute themselves and
Okay, fine. Fair enough. Okay, cool. So thank you so much, Charo State University, for inviting me as a guest speaker here and giving me a luxurious or a pleasant opportunity to talk to the bright mindset of the people who is going to be the new trendsetter in the industry. And it's my pleasure to be part of and associate with this university for the second time. I think I conducted a DevOps bootcamp in the past for the faculty of this university. Now I think the second time I'm going to try to talk to the actual people or actual students of this university, and I always love to conduct different sessions for the students because they are the bright future of this industry. With that, let me quick start. Let me share my screen and go ahead with my presentation. Let me know once my screen is visible for you guys. Is my screen visible?
Yes, it is.
yes, sir. It is visible.
Okay, awesome. So before we start, I would just call out a couple of things. Please, this session is for you guys. So just try to make it more interactive. If you have any questions from the organizers, from the audience, please feel free to unmute yourself, pause me. I won't feel bad. Don't worry about it. Please pause me and ask your questions. Just want to be sure at the end of the session, you guys really understand in and out about what you're trying to cover in this session. And again, as Sir clearly mentioned at the beginning, this is for you guys to understand for your placement, for your higher studies, right? And something to learn because of the time what you're investing in the weekend, the time which is invested by your faculty to organize this session. So please, if you have any questions, don't hesitate. I'll be more than happy to answer any of your questions. And at the end, even if you have questions like why AWS, how I can start my career in AWS, I'll reserve 15 minutes of that slot also if you have any other questions outside this particular session. So with that, let me quickly start with today's session. So today we'll be talking about AWS serverless, right? Now, I assume you guys, in this particular audience, already knows what about AWS is all about. Just in case if you are pretty new, that okay, for the first time you have joined any such kind of session and you don't know what about AWS is, let me quickly give a quick readout about it. AWS, you can think of more like a public cloud offering given by Amazon, which is named as AWS, Amazon Web Service, right? This is like a public cloud which Amazon provide a platform where you can leverage different services, right from database, DevOps, storage, different computes, different processing capability, machine learning, and all those. They provide 200 plus different services under one umbrella, one ecosystem, with a thumb rule of pay as you go and simplifying the entire experience of the customer. So those are the two things at a broader level I can define. Again, uh, there is much more to learn, much more to explain. This two-liners for sure will not help you guys to understand and explore AWS. So, but for the people who are pretty new, this at least will help you to connect the dots with it, right? I think my introduction has already been given by the host. He covered up pretty well about what I do. So I work as a lead architect at Quantify. Along with that, I'm an APN ambassador. You can reach out to me or follow me on LinkedIn, Twitter, and GitHub. I've given the links. I'll also paste the links in the chat. I'm sorry, I can't paste the chat, but I will share this presentation with you guys. So if you have any questions, queries, you can reach out to me in any of this forum. You can follow me on GitHub, the different blogs which I write, and you will also get to learn something new, which is happening as a trend in the industry. as well as the things which are the new features and new announcement that comes from AWS. So please do reach out to me and follow me to learn from that. From an agenda perspective, today we'll be covering around serverless in and out. We'll be talking about what exactly serverless, why serverless. We'll do a demo around it. We'll also go deep dive or dissect what demo will be doing, right? How exactly that thing works. What are the other offerings AWS provide in terms of serverless, which works more in and out with it. And then we'll see a good demo around it. On the right hand side, you can see a different services which Amazon provides. Again, this all services are some or other way not serverless, but a simplifying the life of any developer. If I club this entire sets of services, right, you can build any beautiful application with very easy way, and you don't really have to worry about how to take it, let's say, for 10,000s of users or for 1 millions of users, right? How we can simplify the developing of the platform. Let's say for a very simple example, if I give, right, since you guys are very new to this entire setup, let's say I ask you that, okay, in the lab of your university, you need to you need to develop a PHP or a web application. You will say, sir, 4 साल वही किया हमने. It's very easy to do, right? You can write HTML, Node.js, and you can easily take care of it. Exactly true. I completely agree. But if I tell you that okay, no, this application which you have built, maybe in any programming or framework of web development, you need to host it in such a fashion that the entire university, across all the 4 years, across all the masters, PhD, the each and every person, right, from your faculty to your administrator department to your students to all the alumni, everyone, which will be somewhere easily, if I put it out, 1 lakh plus people need to view it. Let's say you are hosting some festival in your college and you need to host it. Then you will take a back foot, sir, nahi possible hoga. I mean, it's a big number. We need too many servers, too many infrastructures. It needs to be, people should be able to reach out. It should not crash. Those are the different things which you will face, right? Generally, when you think about that kind of user. Forget about that also. Let me take another example. Most of the people are very active in online shopping nowadays. In online shopping, have you think about the different sales which you have on Amazon.in? Big billion sales, freedom sales, those kinds of different sales and offering that have. Now, you might have shopped something from that offering, or you would have at least heard in newspaper or in television. Just think of it, the number of people who would be active during those 3 or 4 days of sale. You can't even imagine the number of people. It will be not 1 lakh, it will be not 10 lakhs, it would be somewhere around over and above 1 crore. And there you need to build an application or a website that can suffice 1 crore people. That's a small, I would say, small window of 4 days. Stock exchange. Do you know how many people work on stock exchange from 9 to 5, Monday to Friday for that platform? Every day, every 5 days. And that platform always needs to be up and running, secured, up and running. It should easily work, as well as it cannot be hacked, right? So those are the different things comes up when you try to build a very scale larger application, which is not just meant for your internal purpose, which is faced by external users. So that I want to set the context here in the agenda slide, so you understand the overall picture about it, that this is not a small program when we talk about in a lab which works pretty well, or in your engineering department of 60-70 people that will work very well. But if we take it to the larger people, larger group of people, how exactly things will work. And there you will see how serverless or different features provided or different services provided by AWS will help you to solve that problem. I hope now you guys can correlate or understand what exactly or what problem are we going to talk about in this particular stuff. And again, if you're still not able to understand it, as I said previously, this session is for you guys. Unmute yourself and you can ask me. Don't worry about that. You will break my rhythm and all. So now if I'm talking about that, you need to build a platform for, let's say, for Amazon.in for a sale kinds of stuff, right? You have, let's say, the next sales, which sale is going to come up in March, let's say year ending kind of a sale, which is going to come out on 30th March, and you need to build a platform. So not only you need to code, which you guys can easily do it. I assume you guys are very good programmers, so you'll take care of that stuff. You'll build a beautiful website. But when it comes to hosting that website, in terms of scaling that website, scaling is ensuring that website doesn't crash when you have more number of people. Those are the couple of things will always come to your head that, okay, how I'll do it. First, do I even know how many people are going to use my website? No. Do I even know when they are going to use my website? No. Do I even know what kind of user they are? Like, are they only going to do window shopping, or are they going to purchase something? If they are going to purchase, how many things they are going to purchase? Or if they are going to purchase, then what they are going to purchase? No, right? It's all unpredictable. A big question mark. We don't know about it. We don't know. We can't even estimate. Can't even guess about it. I mean, it's very difficult, or I would say there's a bad thing which we'll ever do in our life when we start guessing that, okay, this people will come up and let's say purchase mobile, purchase laptop, or purchase television, right? It's a very big mistake what we'll ever do when you're designing the application on the cloud. So there exactly, if I tell you that, okay, I can give you an application or a service where you don't worry about the skill. You only focus on writing the good code, maybe in Node.js, maybe in Java, maybe in Python. You write beautiful code. Don't worry about whether it's 10,000 of users, 1 lakh of users, or 10 lakh of users. For sure, you will say that, okay, yeah, that's the best thing of simplifying it, right? There exactly you will see that serverless is meant for that, right? So now let's quickly go through this readouts and you will understand what I'm trying to say. What is, first of all, a serverless? Now I'm not talking about any AWS service or anything. What exactly is this serverless term mean in general? So it's like a cloud native platform. Again, we'll go in detail what exactly is cloud native, but it's a cloud native platform for short learning, stateless computation, and event driven application, which scales up, scales down instantaneously and automatically, and charges for actual usage at a millisecond granularity. Now let's try to understand each and every term which has been given here. It's a cloud native platform. Again, serverless offerings are being given by all of the stuff. I mean, I would say all the cloud, public cloud, which are available in the market, everyone provides serverless. AWS was the very first cloud in the market to provide serverless service, which was AWS Lambda. It was available somewhere in 2015. It was the first service which got announced as serverless by AWS. Now, it's a cloud native. Any cloud you pick up, when you talk about serverless, it's a very native. It's native to the cloud, because native word means that the cloud partner or the cloud platform from which cloud you're using, right? Like, for example, here we are talking about AWS. So AWS is responsible for managing the infrastructure, managing the scale, managing the load, that and ensuring that your Lambda as a service, or the particular service which you are using under serverless, the service itself doesn't go down. Like fault tolerance, what we call in industry, like it's always available. Those are the couple of things. When AWS takes up the responsibility, that particular service you can think of as a cloud native. So serverless, any offering which is provided by AWS, falls under cloud native offering. And what exactly, or when we should use that? For short running and stateless computation. Now, short running is any function. So you guys know programming language, object-oriented programming pretty well. And in every object programming, there is something called as methods or functions, right? That's how you logically break down your program. Now, technically, you can think of Lambda as one function. That function can simply, you can think of writing it into database or reading it from the database. That entire code snippet which you need, initializing the connection with the database, providing the connection bridge of the database, firing a query, initializing the query with the variable input given from the user, reading the response object, and printing that response object, or processing that object, what you get, the response object. All those 5 things what you do in general, right? And the output will differ from query to query. If you're firing select, insert, update, delete, truncate, it will all depend what you're firing, DML or DDL. But generally, you'll do this 5 steps. When you talk about one Lambda is what you do is like all things which you required for, let's say, selecting a particular row from the data from a given table of a database. So that's as called as a function where you do only one thing at it. Now, again, this is the best practice which you follow. This doesn't mean that you cannot write everything like select, insert, the entire stuff, which I will talk about in upcoming slide, why you should not do that. But for now, just assume that any one operation which you do on database, that particular code snippet, you put it as a part of your function. And that function, you can put it in Lambda. So it should be short running, because if I talk about any database operation, it won't take more than a minute or two. It's a stateless. Stateless means once you fire that application, let's say once that particular function get executed, even you execute it again, it will start from scratch. There is no no chaining, that whatever the output you got from the previous function, you will use in the next function. No, let's say for example, you got select. Now select is completely independent. You can give the input to select, but whatever output you get from a select, you will just print and you will be done. You will destroy that entire stuff. And again, it's possible that you can get that object and you can give it to another function. But in case of Lambda, that's somewhere not possible, or you have to write some additional code. In Lambda, it simply means if you're ending you select after printing that response or storing in database or giving it back to, let's say, some file or UI, that kind of application, Lambda makes sense. Again, it should be event driven. Now it's like event driven means you can think of for any action, like any action, what you have action, maybe someone trigger, someone invoke your function, someone give an API request to it, or let's say someone you schedule it, right? Schedule like an alarm that, okay, every 5 p.m. this should work. Those are the different way you can run this Lambda function. The benefits of using Lambda is it will automatically scale up, scale down automatically, and the charge. The biggest thing is the charges what you have to pay is a millisecond granularity. So you're not paying for 1 hour, you're not paying for entire day, you're only paying for bare minimum on microsecond or millisecond level what you are using. Now, if we think in the larger picture, the advantage you will get on the right hand side, which you can see, is you're only focusing on your code. You don't know about the infrastructure, you don't have to worry about it. So that becomes very easy for you guys, that you keep writing the code. AWS will take care of scaling that code. Less of overhead. So you really don't have to worry about how I'm going to scale it, how I'm going to take care of it. Better focus, because now you're only responsible for writing your code. You can increase it very easily. If I talk about Lambda, if I tell you that, okay, hey, this is the Lambda you have developed, you take it across your entire alumni, whatever you had from the beginning of your university. It's very easy. You really don't have to do anything. AWS will take care. So you can easily increase it. It's very flexible enough. Like flexible today, let's say if I tell you that, okay, you want to increase for your, just take this application across your entire university. Or if I tell you, take this application for just for your computer science department, it's very flexible. And you can easily go and reach out to the larger audience. Now, taking that Lambda, what you've developed, taking it to your entire computer science branch, or you taking it to entire your strength of Charu State University currently, or you take it to all the alumni. It's very easy to reach out to the market very fast, because the Lambda which you develop once, the AWS will take care of scaling it up, scaling it down, and the cost wise also, you only have to pay for what you use. So those are the different benefits and advantages, or you say, of using serverless. I hope this slide is very clear, because after this we'll go in a fast pace where you guys understand, and that's why I spend more time to make you understand what exactly is this serverless all about. Now, why exactly serverless attractive? If we take the same thing what we have learned in the previous slide, very detailed, serverless from that means no server, or very less about server. So what would be your thought? Is it serverless means no server, or very less about server? Can someone help me out by unmuting yourself?
Very less server.
Very less about
servers.
Okay, how you can think of very less about servers?
We don't have to provide the servers by ourselves.
Exactly, that's correct. And someone can also tell me that, okay, no server, right? That it's technically no server. So I would say you both are right to an example. First of all, as an end user, I would always say no server, because when I'm deploying a Lambda, I would say no server. But behind the scene, Amazon do deploy the server. Okay, that's a fact. So it's not, you can think like as an end-to-end, you can't say that, okay, it's no server. Some or other way, if you are not taking that responsibility, your cloud partner is taking care of responsibility. That's one. Second, worry less about the server. So I think the answer which I got from the audience, which was correct, you don't have to really worry about the server and the scaling part. AWS will take care. So you are worrying very less about the server. Second, as I said in the previous slide also, run code only on demand or on request. So that simply means on an action, which we'll learn. I mean, don't just now currently understand about the action, but how those actions are, what are the different services, which we'll see different patterns and use cases in upcoming slides. But you can run the Lambda on demand, you can schedule it, or you can trigger it. So request, any given request based, it can easily spin up and spin down. Your entire app development becomes very easy, and it also saves the cost for it. Hope I think everyone agrees with those points, right?
Yes, sir.
Now, someone can also ask me that, okay, why are you heavily promoting serverless? What serverless is given to you, right? Because, I mean, what you tell me about, I can get the compute, I can easily write the program, it can run on demand. I can do everything on my laptop also, or in my lab desktop, which I've given. I can do that where also, right? So here is a quick chart. Now, there are a couple of factors where I've given specifically from industry perspective, so you can understand what they are trying to compare. But for your understanding, I'll try to break it down in a very simple language. On-prem means anything which you do physically. So just think of anything which you do in your lab section, like in your university, in the laboratory, what you do, that you can think of as an on-prem. Virtual machine, simple. If you guys have ever worked on a cloud, any cloud, so you spin up a compute machine like EC2, that is virtual machine. Containers are like, you can think of, everyone would have heard about Docker. I think I'm pretty sure everyone in this crowd would have heard about Docker. Docker
Yes,
is
sir.
container.
Yes, sir.
Correct. And the serverless means Lambda, and there are other different offerings given by AWS. Now, if you take this example of 4 different kinds of varieties and 3 kinds of features, the time required to provision. Now, tell me the time that required to set up a desktop in your laboratory. It is minimum a day. Like you need to purchase the desktop, install the OS, install the antivirus, connect it to the network LAN, provisional the user and password. I think it's very simple activities which you can understand that it's going to take minimum 1 day, and you need 1 person like a lab assistant to take care of that. When you talk about EC2 instance, I'm pretty sure you guys would have used EC2 instance. How much time did you took to spin up an EC2 instance? For the first time, maybe 15 minutes or 20 minutes. For the second time,
Yes,
maybe
sir.
15 minutes. And now if I talk about, let's say after 4 or 5 times, it's not even more than 5 minutes, correct? So in minutes, in short. If you would have always worked on Docker or something, which is like a layer over and above an EC2 instance, if I talk about only that layer, it's seconds to minutes. I'm not sure whether you guys have used a Docker or not, but if you ever use Docker, it's an abstraction layer over above EC2 instance in a simple language, which will take between seconds and minutes. And at the last, serverless. Serverless, as we talk about, you neither have to worry about spinning up the infrastructure, neither you have to worry about the scale. The time taken is in milliseconds. Like you just send a request, Lambda will come up, it will execute and get you the response, whatever the response is, success, failure, and done. So the time required to execute, I mean, to set up the infrastructure to execute the application, it goes from drastically when you move from left to right. Utilization. Utilization also is the same thing. Now, desktop, most of the time on, if you think about your laboratory desktop, it will be only in use when someone is really working on it. What about the Diwali vacation? What about the weekends? What about the examination times? I mean, most of the time those labs are very empty, or once your college is done, like in the evening, late night, those labs are there. No one is using, right? So the utilization is very low. If you talk about EC2 instance, it's high. When you don't need it, you can stop it, right? And there is no cost to it. Containerization is higher a bit, but when it talks about serverless, it's highest. You can correlate this point with the thing if you talk about in the previous slide, it's short run and stateless, right? it will only be available up to a given time frame. Once that particular execution is done, it will delete itself and you have to relaunch a new one. So that means the serverless is only available when you're utilizing it. It's not available when you're not utilizing it. So the utilization is going to be always highest. That it will only come up in and work, carry out the work which you ask it to do. Once you don't ask him, it will just delete itself. So that's why you can see the utilization. The charge on-prem side, you can understand getting a desktop, it will easily take 45 to 50,000. EC2 instance, I mean, hourly basis you can think of, or minute basis you can think of. Container again on same lines, minute basis. Serverless is milliseconds, as we saw in the previous slide also. On the block of milliseconds, what you're using, you're paying for it. So in all the fronts, time to provision, utilization, and charges, serverless stands out very good. But again, I would warn you, I mean, by now you would be very excited. Serverless is the change. I will let you know there are a couple of examples, a couple of my experiences with serverless doesn't work out well, which we'll cover up in the last few slides. By that time, you guys will have complete understanding of what exactly is serverless. But just remember one line, serverless is not always a go-to service. There are certain scenarios, certain application where even you need containers and EC2 instance. Now, this is exact the same slide, the table, what we have understand. If you see on the y-axis, you will see the business logic, right? The productivity. On the x-axis, you will see the decrease of concerns and control. So that also means if I said that AWS cloud is taking care of everything, so you can also ask me that, okay, in that case, shouldn't I have any control on my server? Because AWS is spinning up the server, AWS is taking care of, AWS is going to scale it. So technically, I don't have any control on my application. What about if I need, or I'm building an application where I need the control? Let's say, for example, I need to decide the port number for my application. Then how I can do it? Or I need I'm building an application which will specifically work, let's say, on Windows system. Then how serverless would work, right? So those are the couple of scenarios where serverless yet is not there, right? And that's how you can think of this particular chart. That as you go from your on-prem to EC2, ECS, EKS, and Lambda, you will see your productivity increases. The focus on the business application increases as per the y-axis. But if you see on the x-axis, yes, that's pretty sure that your concerns of infrastructure also reduces, but you also reduce or you also minimize the flexibility. As you move top to the ladder, the flexibility is very minimum. Now you have to only use particular type of OS, particular type of settings and configuration, what Amazon provides. But if you go back to the bare metal, like in your desktop, like which is provided by in your college or in your laptop, you can do anything. You can get like a Mac OS, you can get a Ubuntu, you can get like a Linux, or you can get like a Windows machine, any version of OS. You can install any kind of software on it. So the flexibility is higher, but again, flexibility is higher, but even the control and maintenance, what you have to do is also higher. So those is where exactly you have to balance. Do you need what kind of application you are going to build, or you are building in your, when you start, let's say when you join any company, what kind of application you're building, what kind of application you will be building, what are their requirements? Is that application is very flexible, then it's fine, you can go with Lambda. Does that application need any specific operating system level settings? Then you can't use Lambda, you have to go back to either ECS, EKS, or EC2 instance. And if they need any specific kind of an hardware that they can't work on virtualization, they need a specific hardware, then you have to discard all this option and to go back to bare metal. So it's very important right from day one, whichever company you join, whichever industry you're doing, or whatever kind of research you're doing for your, let's say, further studies, it's very important that you analyze the requirement. It's like in schools, right? In junior KGs, we used to have this match the column kind of stuff. You have column A, column B, and given the column A, you try to match it. This is somewhere similar. You can think in a very simple language. You, on the column A, you have all of your business requirements. I need to do X, I need to do Y, I need to do Z, I need to do in this particular pricing. And in column B, you can think of different AWS services what you have. Based on the given business requirement, you have to match the column. And it's there exactly the job comes up. Whichever role you go, it's very important that you understand or analyze the business requirement. That always why. Like in last 7 years, one thing which I have learned and which I follow very religiously is why I want to do it, or for what I want to do it. That's helped me to get a very clarity in my head that, okay, the things which I'm building, why I am building it, for whom I am building it, and what this application is going to do. If you get this why very clearly, that question mark very clear, any application, any business problem, you can easily solve. So do remember that that's a thumb rule that will help you.
Hello, sir. I have a question.
Yes, please.
How is this feasible at enterprise level? So on-prem servers are like kind of one-time investment, but the company has to keep paying the provider for serverless.
Correct. Very good question. What's your name?
I'm hit.
Hey, very good question. So I was expecting this question. Okay, you exactly mentioned that. Okay, hey, the industry will, when let's say, as you said, desktop I need to pay 50,000 rupees. 50,000 is a one-time cost. That's exactly correct. Think of that. That's exactly the big gap comes up when people talk about using the cloud. 50,000 is a one-time cost. That is correct. But what about the things which you required in the backend? So if you go ever in the weekend in your lab, right, there is an operating system license you need to purchase, which is an every yearly cost. You need to pay the salary of the lab assistant, some humans to maintain the server. You need to pay the cost for your network, internet cables. And on top of it, something goes wrong in the hardware. Let's say your hard disk crashed, your RAM crashed, your desktop got broken, or power supply is not working. Those different hardware components are not working. So as a user, we feel it's a one-time cost. But if you really analyze it, it's not one time. It's a recurring cost. Okay, not exactly 50,000 rupees, but it's a recurring cost that you have to pay. Maybe let's say 50% of it, 25,000, 20,000 of it. Correct?
Yes, sir.
And when you think similar on the cloud, as you correctly mentioned, you have to pay the cost. Now, AWS is not asking you pay, even if you're using my cloud or not, you always pay me 50,000 rupees, right?
Right.
They're only saying whatever you pay, whatever you're using it, just pay for that to me. So that's exactly the differences. Now, if you use, let's say, if you're a very big, large bank, so there are different banks also who use cloud. If let's say you're a very different large bank of India, your user base will be very higher, but similarly, your headache is also less, right? That no problem of network down, no problem of infrastructure, no problem even on humans. Like as you will start growing an industry side, you will see certain times people are not available. They are on vacation, they are on sick, XYZ. Like think of an example in the COVID, right? When you were in the COVID, let's say you only had one lab assistant in your college or in your department. That lab assistant, it should not be, but let's say he's out of the college on some medical leave. How are you going to handle your lab? Correct. Similar is the many scenarios you will get when you're working in industry. When you depends on people, the biggest problem that comes up always is people will not be available. At least none of the people can work 24/7 always, but machine can does. Which we'll also see in the upcoming session, in the session 2 or 3, like why exactly or how exactly industry eliminates dependence on human in form of DevOps and other thing, which we will see in the upcoming sessions also. But for now, you can think of this example, and I think that should answer your question, correct?
Yes, sir. And also, how does it handle the denial of service attacks? Because on-prem servers go down all the time. So does having serverless website hosted help with that?
That's a very good question. Again, I think you're very, very smart with the cloud. I should appreciate that. So when it talks about attack, okay, attack I will put it out my perspective on attacks. Attacks has nothing to do whether you're working on-prem or whether you're working on the cloud. Okay. Generally, people always think, be transparent. People always think that attacks more happen on the cloud rather than on-prem. I would correct it. Attack is agnostic, whether you're working on-prem, whether you're working on the cloud. It's about what are the best practices you follow. Every cloud vendor, specifically, I've gone through AWS in detail. They always tell you, here are the 15 best practices which you do. Here are the 20 best practices which you do. When you don't follow that or those best practices, then you are prone to be attacked. Similar is the on-prem. Very simple. If you let's say you open up your networking port, you have the access key. I mean, you have your password stored somewhere in GitHub, or let's say somewhere publicly available. Wherever you're working in on-prem, you're working it, let's say on the cloud, you're going to be attacked. No one is going to help you there, right? So attack should be agnostic whether you're working on-prem or on the cloud. But again, the best part, how we can minimize or how we can simplify certain security levels to reduce that number of attacks. There you see in on-prem, you're fully responsible by installing the firewalls, by installing certain other mature security products. In case of cloud, AWS itself provide a couple of services as a part of their offering, which you can enable it, but it's your responsibility to enable. Got it?
Yes. Clear, sir. Thank you.
Yeah. So that's the big difference, I would say. Moving towards the next. So I was talking about, one second. So as we're talking about what is exact the trigger is, right? I'm constantly talking about event-driven, event programming, on demand, it will execute. Let's try to understand in detail how exactly that on demand or event-driven works. Okay. So basically, let's say this is, you can think of any source, anything which is going to perform the action, which can be even humans. This is your Lambda function. And this is the any outcome what you want to do. So technically, this is called as events. This is the function and this is the action. Now, event can be anything. If I keep, let's say, cloud or Lambda, everything aside from the discussion, let's say you're running a student group, right? You have a student group. Whenever a new student register in your group, you want to send an email to him as a welcome. Welcome, thank you for joining our group. Okay, that is one application you want to build now, and it should be very real time, like in 5 minutes, whenever a person joins and just enroll in your group, you want within the 5 minutes, you want to send an email. Think of it. Let's say someone joins your group at 12 a.m. in the midnight. Would you be able to send the email in 5 minutes? No, right? So there exactly what you do is whenever a person, let's say for example, whenever a person try to enroll in your student group, that is called as an event. Someone try to enroll, someone try to access your student group. When that event occur, you can configure the Lambda function and you can write in any of these programming language, whichever you're good with it. Let's say you're good with Node.js, you're good with Python, Java, C#, Go, Ruby, any programming language, what you're good with it, right? Given from this list.
Sir?
Sorry?
Sir, your screen was unshared.
1 second. Thanks. 1 second. Let me share it again. I think it just went on. Is it visible now?
Yes, sir.
Okay. So as I was talking about event, right? So anything when a person tries to log into your student group, that is called as event. Now, what we want to do as an action is once a person successfully registered in your student club, we want to send an email based on the email what he registered with. So I write a programming code in Node.js, Python, Java, any of this to send an email, right? As soon as the person performs that event, Lambda function will get triggered and it will send an email. That's a very simple example. Now think of it, you can take an industry experience perspective in the previous example itself, where someone talk about the attacks. If an attack comes up, right? Now in case of on-prem, You really need to understand when that attack happened. And again, it's not a plan activity that you know that the attack is going to take place at 10 p.m. in the night. It's going to be any time. When even you're sleeping, let's say 4 a.m., there can be an attack. Such kinds of such kinds of things are very helpful in such scenarios. Let's say even you configure that, okay, anyone try to log into my website from this particular region or this particular stuff, you trigger a Lambda. First, you stop the application and send the notification. Easily, you can stop that kind of an attack with such kinds of an automation tool. So that's exactly what comes in event. Any kind of, this is a 2 example, but you can think any kind of thing. Someone tries to register to your college event. Someone, let's say, try to make any sorts of database activity. Someone try to select, insert, create a table. Those all called as an event. On that event, you can try to execute a Lambda function and perform any action to it. So that's what called as an event-driven programming, that you run a code in response to of any event. I hope this is very clear. I'll take a pause. If you have any questions, please raise your hand. Otherwise, I'll go towards a quick demo.
Sir.
Yeah.
Sir, can auto scaling be performed using Lambda?
Auto scaling can be performed using Lambda. So technically, yes. But again, auto scaling itself captures via CloudWatch. So I think that's a very good question. But for the people who understand deep dive, in real life, I mean, if I talk about auto scaling perspective, auto scaling means that you need to scale the infrastructure, correct? Scale the number of EC2 instance. If you configure the right metrics itself, the CloudWatch metrics where you're tracking this entire auto scaling policy or the factor, that itself can scale the server. But again, the answer to your question is you can perform any action with help of Lambda. You can be as simple as sending an email, as simple as launching a cloud formation, or you take any action against any security breach, I mean security attacks. Because as I said, you can write a programming language in it. So that simply means you can do anything there. Okay. But one thing you need to be very sure is you can do anything which is within 15 minutes, because one Lambda invocation can only live up to 15 minutes. So if you're building something, let's say any kind of a form, and that form will be it's a very big form. Let's say it's your university enrollment form. And if you feel that that form is very lengthy, let's say it's 15 page, anyone will not able to cover up in 15 minutes, sorry, then Lambda is not meant for such kinds of use case. Lambda is only meant for use case which are shorter duration, as we understood in the previous slide. Anything like, let's say, a quick retrieving a row from a database, inserting a particular row in a database, let's say rightly mentioned performing an auto scaling, or let's say saving, stopping in security attacks. Those are the couple of good examples you can think of when it comes to the Lambda function. Hope I'm clear.
Sir, retrieval of glacier storage takes more than hours. So, sir, can we use Lambda?
No.
Like establishing.
And again, I would say, see, you have to understand it. What we are trying, we are trying to deviate a bit here from the actual discussion, right? Because Glacier and all, there are many people who might not be knowing about the Glacier. But given, let me explain you. Glacier is an asynchronous process. What you're trying, as I said, right? It's Glacier. What you're doing technically is you're firing an API, and you're telling S3, please retrieve this object. S3 will say, okay, I will retrieve this object on the given location, and in the backend, it will keep doing the process. When in case of Lambda, when I say 15 minutes is for the synchronized event. So if you have any asynchronized, let's say any kinds of application which you just want to trigger, even if it takes, let's say 2 hours, you just want to trigger, fire and forget. We don't know whether it successfully got deployed or not, whether it is available or not. In such case, you can still use Lambda, even if it takes, let's say 5 hours.
Yes, that was my question. Thank you.
Yeah. So if it is more asynchronous kind of a nature, yes, for sure you can use it. That's like an event only. But if it is a synchronized, that no, you need to wait for the entire thing. Like for a very simple example, cloud formation, or any sorts of deployment of any big platform, enterprise platform, like SAP and all those kinds of big platform, which will not get finished in 15 minutes. But if you just want to trigger it and you're pretty confident there are other things which will take care whether it's got deployed or not, then you can use Lambda.
Yes, thank you.
Okay, now we'll quickly move to the demo, right? So what we'll do is I've already had, this is my lab section, so I've already have my IAM role and all, but just in case if a person doesn't know how to play around with the IAM role and it's very new, I've given a cloud formation, and this link I will share with the organizers with your faculties, and they will circulate with you. This particular repo will have everything. The presentation from today's session, as well as the code which I will be using for today's session. It will hold everything. So what we'll do is we'll do a quick demo here. So this is my AWS console, and this is my GitHub repository. You can see my presentation as well as my code, everything. I have already created the IAM role. So again, if you already have your own IAM role, that's fine. If you don't know, you can just deploy this stuff, this cloud formation. I will move to the next step where we create the kind of a Lambda function. So as you can read the steps, navigate to the AWS Lambda service. On the Lambda console, click on create function. In the create function, enter the name, the kind of programming you need to provide. You provide the IAM role and create function. Don't worry, we'll go live now. So which is you can see in this particular screen itself, like everything is on the screen. First, you go search Lambda. Okay, now you can see I'm in the Lambda console. 2, as what mentioned, click on create function. Now here there are multiple ways you can do. You can create your own function. You can use the blueprints given by AWS. You can use the container images, like the Docker images also within the Lambda, or you can also use the public or you can community application which is built, right? You can use any of these things. For the one, we'll use the author from scratch. So you can give any name, like whatever you name it, but again, just have a meaningful name, which will help you to understand, is this what kind of Lambda function is, right? Let's say, for example, giving hello world. Runtime is which programming language and what version. So I'll say 3.9 or I'll go 3.7. Again, we can skip this. Architecture is what kind of architecture you want to use, like the kind of system architecture where exactly your Lambda will be using. Do you want to use Intel versus ARM, which is fine. We can keep whatever you want. You can leave it default. This is very important. Change the default execution. You can use the existing role. Do ensure if you're launching the cloud formation, the role will be created in this particular pattern. This cloud formation -IAM is, cloud formation is my stag name, like whatever the cloud formation name I'm giving. IAM-policy XX, that you will get it from the drop down here itself. So here, since I have not launched the cloud formation, I'm using my available role. I'm selecting it and I will click on create function. IAM role will simply give the permission to the Lambda function to execute. Now this, a very good Lambda is already here. Like technically you have everything. What you can do, next step is under configuration. Yeah, under configuration, you need, under general configuration, you have to define few elements, like what kind of memory you need and what kind of timeout, like in how many seconds, how many minutes it needs to be killed or it needs to finish its work. So we'll keep the memory as is. In the timeout, I'll make it, let's say 1 minute. Okay. And as you can see, you can go up to, see, it's giving the counter. Maximum timeout is 15 minutes, as I mentioned. Okay. So now we will save it. And if I go back to the code, let's say what I'll do is will just simply test this hello world, right? So it's just giving us hello from the Lambda. This is the default code snippet which you receive. So I'll click on text. Now test is, as I said, Lambda is an event-driven programming. So you have to pass certain input to it to invoke the Lambda function. Let's say we pass as I pass this same one and I give it sample demo event. And I create. So this means my Lambda function will be invoked with this particular event. And I click on test. As you can see, in a fraction of a second, I've just given the by default, the default programming code snippet which I've got, I've just add here. 1.63 millisecond. In that millisecond, I got my response. So neither I have spun up any infrastructure, neither I have spun up any sorts of VPCs or networking. Technically, I did nothing outside deploying the Lambda and providing the right IAM role. And if you can see this metrics, your Lambda got executed for 1.63 milliseconds. You are being charged for 2 milliseconds. So as I was saying, the charges are on milliseconds. So you can see the charges are on milliseconds, not on even seconds. And when you're talking about the Lambda, the couple of duration also matters is the memory size. You need to be very sure that you're not only just providing the right timing, but even the memory, because the cost of the Lambda is heavily dependent on two factors. One is the duration the Lambda is running, and second is the what memory you are providing. So as you provide higher and higher memory to it, let's say 1 gigabytes, 2 gigabytes, the cost will also increase. So do remember that. Now what we'll do is we'll replace this code with our sample code. So I've given the sample code here itself. You just have to copy paste this code and deploy. Deploy means save. Now what we'll do is, again, as I saw in the previous demo, you have to pass the sample event. So we'll also take the sample event, which is also given in the GitHub. And I'll configure a new event. Let's say I make it a this is my this is my sample event 2, where what I'm giving is number 1 as 10, number 2 as 20, and then click on create. So now you can see this is my code. I will click on test, and you can see that you start getting the kind of code what you have written. So in this code, if you go back and see what we have written here is number equal to, you get the number from the JSON, you plus, you product, difference, and divide. And then you print the kind of difference. That's what you're seeing here. This was my input, and this is what my output. Again, if you see a small difference, the previous program took 1.6 milliseconds. This program took 1.8 milliseconds, and you're being charged for 2 milliseconds. So it, as I mentioned, it's going to round up. If this, let's say, goes to 2.01 millisecond also this duration, the build duration will be 3 milliseconds, which is fine. I mean, it doesn't matter. Milliseconds is a very small time, but those are the small things you can observe from the logs of this Lambda. So this was a quick example how you can write the Lambda. Any questions here on this demo?
No, sir.
Okay, so this is how what we have done. We went to the Lambda function, we open the console, create a function, assign the role, and click on create function. And then finally, the code, which the same code, the link has been given here. So you can point it from presentation, or you can directly point to the repository. You can click on and you can see the output. So those were the two quick demo, and this is an hello world demo. So you understand how exactly things works on AWS console. Now, if we try to break down the Python code, this Python code, what we have written. So first, there is something called as handler. 2, that is called as event object. And 3rd is called as context object. Now, this is a default code snippet I have given to you. And again, this structure will remain the same. Like these 3 things will remain the same. Within these 3 things, whatever and however you can write the complex thing, that is fine. But these 3 things will always remain the same. So first is handler. What is this handler? You can simply think of a Lambda function name. So anything which is a Lambda function, like here is called as a Lambda handler, here also is Lambda function. So function name which you want to invoke is called as a Lambda handler. So your Lambda will invoke that particular function is called as a Lambda handler. So function to be executed upon invocation. Event object is in short, event object, you can think of the input which you give to the Lambda. So in our case, if you remember, I've configured this test event, like 2 of the test events. So that is what is an event input. In real time, it can be any event, like the event which gets generated when you upload a file to S3 also is an event. And context is, you can think of the additional things about the Lambda, like the request ID, the CloudWatch logs, which it's going to write, right? So now if you go here and under monitor, and you can view the logs also in the CloudWatch. So all those kinds of detail, right, in the Lambda. So if you see, I've made 2 invocation and this was the outcome. So if I put it in the viewers text, so this is the same output you got from the console as well as in the CloudWatch logs. So all those things, like when you talk about context, everything, like things such as how much time is left for the Lambda to before it get killed. Like if it overrunning from the defined window, how much time that is left? What is the request ID? So each ID, even if you're executing again and again with the same input, there will be a different request ID. The CloudWatch log group. More details about the internal Lambda that you can get from the context object. So these are the 3 basic things which you need when you're working on any, from simple hello world to the complex Lambda application. And here you can see the simple code snippet. Like simple, this is like a print statement of hello world. If you go here in an example, this is like a very complex, I mean, not complex, it's a very simple arithmetical Lambda function, or the Lambda function which we'll do in upcoming demo. So that's about the walkthrough. Now quickly understand a couple of more things, couple of other services which we use. Technically, I also use when it comes to industry in and out. Step function. So as I mentioned, Lambda is used, let's say, for doing all the processing and all. One thing is also very important from that to understand is that, let's say, if you have multiple Lambda, the simple example which I gave to you, that someone try to enroll into your student club and you want to send a kind of an greeting. But if I tell you before sending a message, you want to do a couple of things, like for you want to even create an account for that person. You also want to do, let's say, personal greeting to that person, as well as you want to, let's say, send some message on the Slack or some sort of a platform to appreciate, not only just an email, but also on the Slack. If I tell you, you have to do multiple things on an event, your answer will be very simple. Sir, we will invoke multiple Lambdas. Correct. But how are you going to track that all of this Lambda which you have been working, I mean, all those 5 or 4 Lambda what you required, did their job successfully? And again, let's say, even if I ask you that for doing all of this work, you need the email ID. So first, I mean, are you going to ask each of these Lambda to go in the database and get the email ID? Or you will try to optimize it, right? If you go with the object-oriented programming, what you will always do is one function, which is a common snip used across all the functions, you will make as an independent function, as in part of object-oriented programming, what we do. They're the same thing, but you can apply in Lambda also. In Lambda, what you can do, step function is more like you can think of an orchestration or chaining. This service help you to chain different Lambda. Things such as passing the parameters from one Lambda to another, validating the response also of one Lambda to another, or as well as asking a Lambda to wait for 15 minutes. Let's say things like, okay, whenever a user enrolls, after 15 minutes only you send it. Those all intelligent kind of decisions, intelligent kinds of processes you can embed here with the help of step function. Like very simple, when the same example, if we take someone enrolls in your student group, after 15 minutes itself, you should be able to send an email. You want that functionality, not real time, after 15 minutes. Now you can't, event means it's a fraction of a second. That person logs in, Lambda comes up, done. But if I tell you after 15 minutes, you can't even put a sleep in Lambda because Lambda is only available up to 15 minutes, then how you can do it? There exactly, step function will help you. Step function will invoke a Lambda. Like you can see this kinds of stuff, wait 3 seconds, those all different kinds of stuff you can do with help of step function, and you can take care. The bigger, I mean, this was a very small example. The bigger example or the best example you can think of, the order purchase, any e-commerce order purchase. Now, when you talk about order purchase, there are multiple activities. There are multiple steps itself, right? First, after the cart, I mean, I talk about, let's say you got a book and you already put it into the cart. Now, what exact process takes place after you put it in the cart? You have to provide your delivery address. I mean, first you need to confirm your order. You need to provide your delivery address. Then you need to provide the payment details. And then you, at the last, you get the tracking details, like, okay, when your book will be delivered or shipped. At any stage, there is a high possibility that is a failure occur. So if there is a failure, you want to for sure ensure the user retry, or you don't want to allow user to move to the next steps. Similar kind of thing you can see, or you can visualize it with the help of the step function. If you want to build that same kind of an application, you can easily do with the help of step function. So there exactly step function works very well. And it's not just limited to the Lambda function. Initially, when step function was launched, if I talk about, let's say like 4 or 5 years back, it used to be only working with Lambda, but now it can also be helpful for big data pipelines. Like if you have any big data pipeline or machine learning pipeline, it can also be leveraged to those services also, not just Lambda, but it's a very good services. Next is SQS. I think SQS, everyone knows about it, but I'll quickly cover up. SQS is the very old service. We always know about S3. We always talk about extensively about S3. We have used S3, we have used S3. But here, SQS is the first and very old service in case of AWS. I mean, it's even old than 10 years. Now, technically, I think if I'm not wrong, reinvented itself as a 10-year. So AWS is longer than that. SQS was somewhere launched in 2006 or somewhere. So it's over, like I would say 14 or 15, 16 years now. It's the first service which was launched by AWS for queuing. Now, many people will say, okay, how this service is anything to relate with Lambda? I mean, we are talking about the Lambda, but why are you talking about the SQS? Think of that, okay, as I said, someone is trying to enroll in your student club. Let's say your student club become very viral. Viral is like people are very happy. You had a very good sessions of AWS, good learning session, and it become viral. Like thousands of people wants to join. And or let's say even you want to have, let's say not even 1,000. If I talk about 1 lakh people wants to join across India, all the students of your India wants to join your group. Then in that case, the Lambda, there is a cap, right? There is a cap, is a soft limit. Your Lambda can only run up 10,000, like different instance of Lambda can run 10,000. Again, you can increase it. But let's say assume you can only run 5 Lambdas, for example. But you want to serve all the requests that comes up of all 1 lakh people. How you would do it? Your Lambda will start erroring out, right? Because at a given concurrent time, you can only run 5 Lambdas. I'm giving an example, hypothetical scenario. And you have 1 lakh people. There you will see queuing makes things very easy. So if you see this particular point, decouple application, this is the best example. And the real best example of decoupling an application is a database transaction. Whenever people always try to write into the database, the transaction, if let's say 10,000 people start writing to the same database table, your database would be crashed in few minutes itself. But if there exactly you have to deploy SQS as decoupling, that directly you don't hit the database. If you want to write something, you save it into the SQS, and behind the scene there is some processor or consumer which will pick one after the another message and will write to the database. The advantage is one thing more, retry. So by default, the message from SQS will only get deleted when you want to delete on, let's say, the things like you successfully process the message or you just perform any action, then only the message can be deleted. So that also ensures without any complexity, you can retry. Let's say, for example, you're writing a particular row in a database and your database got crashed. Technically, you don't even know whether it got successfully written or not. But with help, if you have an SQS, your message is not deleted. So it will go back to the queue and it will be picked up again, let's say by another Lambda or another EC2 instance to ensure that your message get processed at least once, which you can simply visualize from this architecture. You can think of this producers are like the different events done by humans, in terms of they want to perform any action on the database. And these are the different, all the SQL statements which get saved into this SQS. Now, this SQL statement consumed by, let's say, you can think of this consumer can be a Lambda, can be an EC2 instance, which consume this message one after the another and perform the required action. Just in case, if a person tries, okay, you may can also ask that, okay, what happens if a transaction got already written in the database and then it got crashed? Technically, in that case, the database message is already written, but you said SQS message won't be deleted, so someone will retry. So there, in that scenario, what you can also do is you can use DLQ. So ideally, the action is already performed and the message will keep occurring again and again. So what you can do, and it will fail because the state of the database or that particular row is already changed. So you can track such kinds of into DLQ, like you can sideline that faulty message and put it into another queue. That you can say that, okay, if a message has been retried thrice and still if it is failing, you can just sideline into a dead letter queue, which someone can look into it manually and identify what was wrong. Maybe someone, let's say, someone didn't provide the right value, or someone didn't provide the value as per the schema. In that case, that message will keep erroring unless someone manually goes and fix it. There exactly, you can also have those more intelligent way via sidelighting that thing in DLQ. So those are the very best thing. And again, there are a couple of other things which you can remember here is it's highly scalable. You can read about 10,000s of per second messages, very low latency. And the best part is default retention of message. This is very important thing. 4 days to maximum, default is 4 days, maximum you can store up to 14 days. So many a times I've seen when I'm working with some other clients, people always do complain, my message got lost. And when we identified, the message got lost because it's over and above 14 days. So if your message is above 14 days, that message will automatically get deleted from the queue. So do remember all those kinds of stuff. And again, there is no limit on the number of messages you can store in the queue. And on the consumer part, there exactly someone asked me that, okay, what is auto scaling? Can we do and all? So this is the best thing. You can use the auto scaling and you can leverage that, right? So you can, this consumer can be Lambda function. This consumer can be a container. This consumer can be the EC2 in auto scaling. So this consumer can be anything which you can scale up, scale down. So that's about SQS. SNS, a simple notification service, which is mostly you can think of, let's say, sorry, go ahead. Any questions?
Sir, in DLQ, you said that we have to perform the manually tasks. So, sir, what if the lateral task in the SQS depends on the task that has gone to DLQ?
Okay, that's a very good question. As I previously also mentioned, right, in that slide, SQS is a messaging. So if you need something in a sequential format, okay, like as you mentioned that, okay, my task my task B should only be triggered when my task A is done. Like if I talk about my insert statement, my insert statement should only be performed when the table exists. If table does not exist, what I'm going to write in it? Correct? Did I frame your question correctly?
Yes, sir.
Okay. In such scenario, SQS is not the right thing. There you have to go back to step function. Because here you're chaining the Lambda function and you're ensuring that the action is done in a proper sequence, which can be anything, which can be, let's say, as an example that, okay, I need to, let's say, create a database, then create a table, then insert it. In that case, step function is the right service which you should use. Because in SQS is a messaging service. It's like a post. How we can sequentially assign the post? Post, I'm saying letter post, not the position, letter post kind of stuff. It can be in any random order. Again, there are queue. AWS also come up with first in, FIFO queue, which we call as first in, first out. That also you can use, but again, it cannot guarantee that you can get that sequential thing, because first in, first out will ensure that your message which enter first in the queue will be removed first. But for example, when entering itself, your insert message goes first and then create. So that's why in given that example, step function is the best way to solve that problem. Make sense?
Yes, sir.
So that's about SQS. As I was talking about SNS, SNS is more about the notification service. So when you, let's say, as I mentioned, SQS is like one-to-one. If you see here one-to-one, that you have producers and then you have consumer. Now auto scaling is one set. Okay, it can be processed by Lambda function or sets of EC2 instance or a single EC2. But let's say if you want that, okay, one message and you want to send it to everyone, like the post for this particular session, your organizer or your faculties created a template that, okay, this XYZ person from random place is going to come up and talk about Lambda. And they want to send like to all of your 100 students. That's difficult, right? That you can't do with SQS. SQS is, if you guys want to register it, then you can do it. There you can see SNS. SNS is more public subscribe. Like since you have subscribed, let's say for an example, do student club, and this activity and event is occurring in student club. So when someone posts in student club, by default, it gets received to everyone. Simple of that example, very simple example can be a WhatsApp group. You have registered as a part of that WhatsApp group. So now when anyone will send a message to that group, that message will be circulated to everyone who was part of that group. I mean, now someone will tell me I have unmute and all of the stuff, but still that message occurs in your mobile. You won't receive a notification, but you will be forcefully get that message in your mobile. Similarly is a kind of an SNS. If you have subscribed to the topic, to the particular channel, you will for sure receive the message. Now the message are sent in two higher categories. It can also be sent to any AWS services, or it can also be sent to person. So application to application, A to A or A to P. Like you can send as a push notification, you can send as a email, you can send as a SMS, as well as you can send it to Lambda, SQS, or any other API services. So many a times what people do is they want to process a particular notification. Let's say, as I was talking about the student enrollment to your club, we want to do multiple things at a time. Like when a person comes up, after you get an email address from the database, you want to orchestrate all 5 things. Again, you can do that with step function also, but you want to process all 5 things. Send an Slack message, send an email communication, let's say create then account or generate some credit codes. You want to do all in parallel. At that time, what you can do is you can send the SNS to SQS. And you can have multiple such SQS like Q1, Q2, Q3, Q4, and each SQS can have different Lambdas, where all those Lambda will kickstart in parallel that, okay, Sanchit Jain joined ASC group. So let me create all of 4 things for him in parallel. That kind of application person can do, and that is called as fan out. Like you're really spreading it in a tree structure from root to the bottom, like a fan out kind of a thing. So those kinds of complex application you can also build. So that's about the quick thing when it comes to about the SQS SNS. Now let me quickly talk about how exactly in real life, as we understood, right, what are the different patterns to it. So I think someone asked me at the early slide, I want to retrieve and file from S3 Glacier, would Lambda be in right example? So here you can see how exactly Lambda or what are the invocation model. So as I talk about synchronize, synchronizes means you want to perform an action. Unless and until that action is not done, you cannot terminate the connection. That is called a synchronize. Asynchronize is like a fire and forget. You want to perform an action, you fire it and you forget it. You don't even know, you don't even care if that particular action is successfully done or not. Polling it simply means that you keep invoking again and again and see. Maybe something, let's say an election count, or let's say some kind of an counter. That every 5 minutes you see what is a new trend or increase count. So that's a poll based. It keep polling it after every 5 minutes or 10 minutes or whatever the period you define, and keep up the new count. So those are the 3 different ways you can think of invoking a Lambda function. Now someone will say, if someone has gone through a cloud practitioner certification, or maybe let's say solution architect, he might ask a question. There's a CloudWatch event. Lambda, generally people say you can also invoke a Lambda function, let's say 5 p.m. You can invoke a function at a 5 a.m. But I can't see that particular execution model in your design. You're exactly right. End of the day, those are the different ways of triggering a Lambda. Which you can also say someone uploads a file to S3 and you trigger event, as we understood in the previous slide. But this slide is more talking about the execution model of the Lambda, not the different types of events. The execution of the Lambda can be of three types, either synchronous, either asynchronous, and either poll based. So don't get confused on the different types of events and the how Lambda works execution wise, or the Lambda invocation wise. Those are the two different things when we are talking about here. So this is a quick slide where you have API gateway. API gateway is like an endpoint which you can define on Lambda, and you can host any APIs, any microservices. So as I mentioned, right, in the first slide, that Lambda is only meant to do one thing. So there is a terminology in IT industry called as microservices. Microservices is like an API which you only design to perform one single function. That function can be as simple as perform a select operation to database, or to insert in database, or to delete a row. Those are the simple examples of microservice architecture, and Lambda is the best example to build a microservice API. So that's this API. Again, as we understood very clearly, you talk about SQS, SNS, you can do around, or Event Bridge, like the new service which CloudWatch even got replaced by Event Bridge. You can have the asynchronous way of triggering it or scheduling your Lambda. Polling is something DynamoDB, you know, all NoSQL database. Kinesis is like a streaming, right? Let's say you have some election, your student club elections are going on around, and you really want to track real time. Every vote a person votes, you want to real timely show who's the winner. Generally, elections are like post. Once you entire elections are done, then you talk about the results, but you want to show real time how you will build that. Similar is the best example, that when someone votes, you keep capturing that votes into Kinesis, and then you have Lambda as a polling, keep polling that Kinesis every 5 minutes and start writing that data into DynamoDB. And then based on DynamoDB, you can show the results anyhow, I mean, in the form of UI or visualization. So those are the powerful application you can build in a very easy way.
Hello, sir.
Yeah.
So for real-time data processing, we can use poll-based, right?
Yes.
Okay.
Again, that depends. I mean, we'll understand it's not meant for every real-time scenario. There are certain cases which we have to be considered when we are using Lambda, but in a high level, yes, you're correct.
Thank you, sir.
Now, let's understand the different serverless architectures. Like what kind of different serverless system you can build. So that's exactly what I was talking about previously. Someone, let's say, uploads a file and puts into S3 and Lambda. So I'll tell you one real example. Most of the time, when I'm working in different projects or different clients and other stuff, right, in my at Quantify, so, or any other application, what happens is there is a kind of a file that comes up, let's say, at any odd time, maybe let's say 3 a.m. IST. You need to take that file, you need to run the Python code on that file, and you need to store the data into database. Let's say that's what an application I'm building. Now, every day it's coming 3 a.m. IST. So are you expecting me to be available at 3 a.m. IST? No, right? But there is an SLA that I have to process that file within 5 minutes. I can't, I mean, at 3:05 a.m. IST, the data of that file needs to be in database because there is some other processing that needs to take care. In that kind of scenario, what generally happens is, or how we can do that, whenever someone uploads a file into an S3, as I said, there is an event that gets generated. You can capture that event and you can send that event to Lambda. And as Lambda is always available, as soon as you get an event, it downloads that. Based on that event, it downloads the file, process that file, and whatever the action you want to do. Similarly, you can think of this one also. Whenever you get any SNS topic, the Lambda will be available. The best example which we understood so far is that student club thing. And this is exactly what I was talking about, the fan out kind of a concept. Like there you have an SNS sends to SQS, and SQS sends to the Lambda. So this are the, like, I would say different, again, not complete list of the architecture which you can build. People have took serverless to a next level itself when it comes to designing the system. These are the very simple and helpful design patterns you can think of. Any question here? Okay.
No, sir.
Yeah, there are different industry use cases. You can use web application, backend, data processing, chatbot, Alexa, IT automation, right? Again, when I say web application, not hosting UI, building the backend APIs, right? That's what you can use for web application for you. You can use, as I mentioned here correctly, data processing. As someone asked me that, okay, can I use Lambda for polling based for data processing? So here exactly that is the one. And the example which I gave, that someone uploads a file in S3 and I want to run a Python program, that is a kind of data processing I'm doing. Chatbot, the very best example of using serverless is a chatbot. So Lex, Alexa, I mean, I'm not sure where you guys have understanding, but let's say you want someone as a chatbot. Now you all know what is a chatbot, the way via which, very interactive way via which you can talk to the machines. In simple, whenever a machine responds, machine doesn't have a brain. I mean, it's not having a brain. You're feeding that intelligent, when you're designing a chatbot, you're feeding your intelligent to the machine. That, let's say someone asks you, hi Alexa, how are you? And you have to say, thank you, I'm doing good. So that response you feed into that particular chatbot. And behind the scene, you have Lambda, DynamoDB, those kinds of different services to process every request that is coming in form of a text or voice from end user and give the response back. So all that processing, the best example to do is Lambda. Again, as you can see here, Amazon Alexa is one of them, and IT automation. So if we go back in the previous example about stopping a security attack, right? Those all things you can do IT automation. Or let's say if someone joins in your university and at the university you want to create their IDs, their email IDs, those kinds of automated stuff also you can do. Currently, your admin team would be manually doing it. But if you want to automate that process, you can also still do it with Lambda. That, okay, hey, you give an CSV file to the Lambda with list of all the students, and Lambda can automatically fire that API for creating the IDs and other stuff. And that was one of the examples, but those kinds of IT automation you can also do. Now, last slides. What is serverless good for? This is very important. I've talked about a lot in last 1.5 hours about serverless now, but it's very also understand. There are certain things where Lambda is good for, certain things where you need to watch out when you're using Lambda. Because most of the people, when you will keep hearing Lambda is not good, it's not working out for me. It's not working out for you because you haven't choose the right service. Lambda is not meant for that particular use case or application. So there exactly you will see. It's very good for short running. Do always remember, any serverless where you talk about, not just Lambda, any serverless service, when you just hear a term serverless, the second thing that should come in your head is short running, stateless, event driven. If you just have this mantra type fixed in your head, you will be success at least 25% in your role in IT industry for cloud. So serverless is good for short running, stateless, and event driven. The more you keep short your application, the best it would be. Technically, if I talk about in 2015, if I share my experience, Lambda was having a timeout of 5 minutes. Slowly, gradually, they moved to 10 and 15 minutes. But ideally, still, I agree with their initial thought process. If you have any application which is within 5 minutes, then you should use Lambda. They have increased the time frame 10 and 15 minutes for any application, let's say, that only invokes once in a day. Like once in a day, it's going to just invoke for doing, let's say, some count. Then even if it takes 15 minutes, that's fine because it's only going to run once in a day. And for that, you can't run EC2 instance. So for those kinds of edge case scenario, 15 minutes makes sense. But if you are very frequent, every hour, every half an hour, if you are invoking a Lambda, which is taking, let's say, 15 minutes, you're going to pay a significant amount of cost. So do remember that the more short application you have, the cost will be less and you will truly get the best advantage of using Lambda. So microservice, mobile app backend, bots, IoT, streaming processing, any sorts of integration or IT automation, those are the best thing you should do Lambda. Database, again, that's a very bad example. I have never seen anyone doing it, and don't even try. Hosting a database on Lambda, not meant for it. Deep learning training. not meant for it. Heavy duty streaming application like video feeds. Someone asked me, I want to do a real-time streaming. Now, real-time streaming can be of text data, like in form of bytes, or it can be also very heavy video. Don't try to do a video streaming kind of thing. Numerical simulation, like some sort of an algorithmic. When you do a research and all, if you want to build some algorithmic, it won't work. Why? Because it's a stateless in nature. So if you need to pass on the values and all, it will stateless in nature. And video streaming. So this is a very bad example where you should not even think of using Lambda, because these are long running. It's not about Lambda bit not able to handle. It's about these are all tasks are long running. So as we understood, when it long running and stateful, but we only will choose Lambda when it's short running and stateless. So here I quickly end my Lambda. We'll quickly go through a quick demonstration. Right. What I'm going to do is I'm going to do a Lambda invocation via SQS. So this is the same Lambda what I have developed, right? We'll use the same Lambda. What I'm going to just do is I'll open up a new page here. We'll go to the SQS. And I'll create a queue. As I said, there are two types of queue. As you can see, at least once delivery, best effort ordering, best effort. They don't guarantee. But here you can see exactly once processing, first in, first out delivery. So as I said previously also, you can use standard port. So I give a name. You don't have to make any changes here. This is just for testing. You can keep everything as is. Create a queue. Okay. Now it's also very important. Once you create the queue, you need to pair or integrate the queue with the Lambda. You can see the Lambda integration here. Configure Lambda trigger. You can do it here. You can, as well as you can add triggers from here also. From this entire list of Apache Kafka, IoT, Alexa, you can do it here also. Okay. We'll do it here. You can choose the Lambda function. Now, this is the Lambda function. Save. What it is saying is Lambda function is 30 seconds and timeout is 60 seconds. So what that means is your SQS message visibility is 30 seconds, which is less than function timeout, right? So what we'll do is now, there are two ways. Either I can go in Lambda and I can reduce to 30 seconds, or I can go to SQS and I'll do it 60 seconds. What I'll do is, as I said, Lambda is short-lived, so I'll try to make it 30 seconds. Okay, and save. As you can see, it's successfully updated. Now I will again try and save this. So as you understood the difference, both the visibility timeout of SQS message should be equivalent to your Lambda function. It cannot equivalent or more than your Lambda function. It cannot be less. Ideally, I would say it should be equivalent of it. So once we solved it, you can see it is already there and it's not integrated. You were seeing like it's creating and now it is enabled. And if I refresh this page, you will see this trigger is to this Lambda function. And if I go to the CloudWatch also, you only can see the 2 logs from the previous execution. Now what I'll do is I'll go and I'll send a quick message to the Lambda function. This is the same message what we have given to the Lambda function in the first demo. The same message we will give it to SQS. Okay. This is a message ID. And now if I go in a fraction of a second, if I go in the queue, it's in the flight. Flight means under processing. And now you will see 0. It got successfully processed. How we can verify it now? Because we were not in the Lambda console. How do I know it got successfully processed? This is the CloudWatch logs. And here you can see. Now someone can ask me, hey, prove me this message came from SQS, right? For my understanding. So if you see here, the event source, as well as the event ARN. If you see this particular event ARN, that shows this message came from demo SQS. So this how it's very simple. In few clicks, you can easily integrate with SQS and Lambda without really going around and scratching your head and doing the stuff. Let's say we'll send one more message. So you can directly click here, send and receive message. put here. Now what I'll do is I'll give it 30 and 50. I'll change the number and give it to get some more fun. Let me send a message. Right now you can see that neither it's available, neither it's in flight. That means it got successfully processed. I will refresh it. And since I fire it, you can see here itself that the logs got appended. This was the execution where we give 30 and 50 and you got the output here. So this is a very quick way you can take care of that particular demo, right? So this is what we have done here. And the steps I've given, this code snippet and everything have already been shared in the GitHub. So that's all what we have from today's quick demo. What I'll do now, I'll just try to make this session very quickly fun. And let's say we'll try to play around with a Lambda where you upload a file to S3 and integrate it, right? Say, so you can really learn something out of this. So what I'll do here is I'll create again a session stuff and I'll name this Lambda get file. Okay. From S3. Now I choose the runtime at, let's say 9, the latest one. Then I'll do the same thing, which we have done in the demo Lambda also. We'll click on create function. Now this Lambda function has been deployed. Here you can see a default snip. This was the same thing. I will go back to my GitHub repository and I'll open a read file Lambda function. This is a Lambda function. You just have to copy paste it properly and paste it. I'll quickly give you a demo. So this is a Boto 3. Boto 3 is in Python SDK for playing around with AWS. So anything which you want to do in Python and you want to interact with AWS, you will use Boto 3. Like how you have Java SDK for working around Java. Similarly, you can think of Python for if you want to interact with AWS, you'll use Boto 3. You are first passing the JSON, the event which you get, right? And what I'll do is I'll remove this indent. Okay. Now, from the JSON, you will get the entire thing. So what I'm saying is, what exactly is the event, right? If I go back here, if you see this particular text, if you see this particular kind of an event, this is an event JSON, which holds entire detail, right? I was easily able to trace, this was an SQS message. This is the queue name. This is my actual body, the input which I gave. Similarly, there will be an event that will also come up when S3 triggers a Lambda. We need to process that event to get the bucket name and key from that JSON. So I can get means download the object and print what kind of file it is. Is it a JSON file? Is it a Python file? What kind of file it is and return. That's what I'm trying to achieve. I'll deploy this. Deploy is saving and publishing. The next, what I'll do is under configuration, I will just increase the time. So try to make it, let's say 30 seconds. The memory I'll keep the same as is. Now, this is done. My Lambda is ready. Second, what I will do is, as we have seen in the SQS also, we'll try to add a trigger. The trigger here is S3. And you see that all details comes up. When you select S3 automatically, which is the bucket you want to do? Let's say I say bucket is this bucket. What kind of event? You can see all list of it, right? From someone asked me glacier completed, RRR loss, any kind of thing, okay? We'll put it like as a all create object. You can also put it like within a specific folder, within a specific file type. That also you can filter. This is called as filtering, right? We'll keep it open-ended for now, for demo, and I acknowledge it. Okay. Okay, the best example, what you can say is an error occurred while creating configuration overlap. Okay, 1 second. I know what exactly the case is here. So we'll go to here. We'll go to the Lambda function. And we'll go to this particular bucket. Here, there's already a Lambda function which was created when I was doing a demo. So I deleted this Lambda function now. I mean, there was a linkage. The Lambda function doesn't exist, but the link does exist. What it is saying, an error occurred when creating the trigger configuration overlap. That means there was already one configuration you're trying to overlap. If I try to add it, and it will save successfully because I delete that link. And if you go to S3, and if you refresh this page, scroll down, you will see a new kind of thing that got added, and you are pointing it to this particular Lambda. So now we are all good with our settings and configurations. S3 is there, Lambda is there, everything is there, all set. Now let's make this run. So what I'll do is I'll add file, and I'll add this Lambda file. So technically the output, it should give me as text/x-python script as the output of the Lambda. So I upload this Lambda and I close it. Now I will go to the CloudWatch. This is my Lambda function. This is my log. And this is my content type. You can put any of the things. Let's say for an example, upload, add file. Let's say JSON. Now I try to upload a JSON file. And again, I go to this Lambda function. I think the second log created. Okay. Yep. The content type, application JSON. And if you see the event, this is a proper event where this is the bucket. This is the object. And from that, you extracted the content type. So here is a quick demo around how we can integrate your S3 bucket with the Lambda, and you can build a very simple and a beautiful application. So that's all what we have from today's session. Now I'm open to any Q&A. If you have any questions and queries, please feel free to unmute yourself and reach out to me.
Hello.
Hello.
Yes, sir. Sir, if we don't configure the timeout in the Lambda function, then what will be default value?
So default, as you saw, right, when I created a Lambda function and I didn't provide any default, the default was 3 seconds. And you create any new Lambda function, okay? And
Yes.
if you don't provide the timeout, it will by default point to the 3 seconds.
So, sir, if my Lambda is still in the process and it is about 3 seconds, then even my Lambda is in process, it will be terminated.
Yes,
right?
it will be killed.
Okay.
It will be killed, and you will see an error message called as timeout.
Okay. Okay.
Any other questions?
Sir, I had a question.
Yep. Yes, please.
Sir, for example, if we take if you want a form which is very long, and for keeping in mind the best user experience, we want to save the form fields as and when the user fills it. So, sir, would Lambda be the best option
Yes.
to say? I mean, write it to the database again and again.
Yes, that's correct. So there are two perspectives. If, as you mentioned, that I want to make it more interactive form for per field, I want to save it, then yes, you can use Lambda. But again, if you think that no, I want to do it at the very end, at the very last, then it depends how are you doing it, right? It all depends how exactly are you doing it. But if it is pure on the field level, then yes, you can use Lambda for sure. Got it, sir?
Yes, sir.
Okay.
Hello, sir. I
Hello.
don't think there is no more also.
Cool. Thank you guys for. Sorry. You want to go
No,
ahead?
thank you, sir, for giving us your special time with us. So,
Thank you so much for being a very nice and wonderful audience. So I think this is a 3-session bootcamp. So this was a session 1 talking about Lambda. We'll have very good, interesting topic in upcoming sessions. So which we'll have in next Saturday and a week after that. So please do join all the session. I'm pretty sure after this, all the 3 sessions, you will have very good understanding and a better learning about each of the topics.
Thank you, sir.
Thank you so much. Have a wonderful weekend ahead. Thank you. Bye bye.